Rab explains it all. Math, chem, physics never fall. Subscribe and learn. Ace every test, so Rab explains it best.
Hi everyone, I hope you are doing well. Welcome to this video and welcome to my channel. In this video, we are going to learn how to interpret a speed from a distance time graph. In fact, by the end of this video, you will be able to gain some information about a speed only by looking at a distance time graph, not by calculation. Okay, let's start. We are going to learn 5 different key points. The first key point says if we have a distance time graph and at that distance time graph, we have a line, the graph is linear, it shows that the speed is constant. Pay attention to the example. Here I have a distance time graph and the graph is linear. So what can I realize from it? That the speed is constant. I'm going to show the constant with CTE. Let's go for the next one. If I have a distance time graph and the graph is a horizontal line, it shows that the speed is equal to 0. Okay, pay attention to the example. Here, I have a distance time graph and the graph is a horizontal line. First of all, according to the key point number 1, we can realize that here I have a straight line. When I have a straight line, the speed is S is CTE is constant, okay? But what is the value of that? Because here I have a horizontal line according to the key point number 2. The value of this speed is equal to 0. Before we start the key point number 3, I prefer to mention some points about a slope. Assume that you want to travel to a destination and there are 2 routes for you. This is the first route and this is the second route. Can you please tell me which one do you prefer to pass? Which one is easier for you to pass? You probably know that from your real life, right? This is the first route and this is the second route. If you are a wise person, you would choose the first path. Why? Because it is easier. It contains less slope. So I can write that a slope of the first one, I'm going to show the slope with m is less than the slope of the second path. Another example, there are 2 routes for you. This is the first one and this is the second one. So this is the first one and this is the second one. Which one do you prefer to pass? Which one is easier for you? As you definitely know, it's understandable from your real life, right? You would choose the path number 2. So I can write m2 is less than m1. A slope of the line 2 is less than the slope of the line 1. Let's go for the third key point. If we have higher slope for a line on a distance time graph, it shows that we have higher speed. In fact, in a linear segment on a distance time graph, the value of a slope is equal to value of the speed. Pay attention to this example. Here, our distance time graph contains 2 parts. This is the first part and this is the second part because we have 2 lines here, 2 different lines here. Okay, in which one of them the value of a slope is higher? Definitely m1 is greater than m2. And because the value of a slope in a linear segment on a distance time graph shows the value of a speed, I can realize that S1 is greater than S2. Really simple. Key point number 4 says that if we have a non-straight line, we do not have a straight line, we have a curve on a distance time graph, it shows that the speed is changing. It is exactly against the key point number 1. Look. Here I have 2 examples. Key point number 1 says when we have a linear segment, it shows that the speed is constant. But when we do not have a linear segment or when I have a curve, it shows that the speed is changing. So in the first example that I have a curve, the speed is changing. And in this one, the speed is changing. The speed is not constant. Key point number 5. It is talking about specifying if the speed is increasing or decreasing. When the speed is changing, it means we have a curve on a distance time graph. Pay attention to these two distance time graphs, how can we realize that the speed is increasing or decreasing? Because as you definitely can see, here we have two curves, right? And when we have a curve, it means the speed is changing. Okay, I'm going to find the initial point. This is the initial point of this curve, and this is the ending point of this curve. I'm going to draw two tangent lines, one for the initial point and one for the ending point. I'm going to call the first tangent line 1 and second one 2. Can you please tell me which one has higher slope? As you definitely can see, M2 is greater than M1. Okay, what can we realize from this? I told you tangent slope or a slope when we have a straight line is showing the value of the speed. So I can realize that S2 is greater than S1. Okay, so I can realize that speed is increasing. This is the first method that we can apply. Look at the second one. This is the initial point and this is the ending point of this part. I'm going to draw two tangent lines. I'm going to call it 2 and this is 1. Which one has higher slope? As you definitely can see, M1 is greater than M2. So I can realize that S1 is greater than S2. What does it mean? It means when we are passing this route, the speed is decreasing. This is the first method that you can apply. What is the second method for specifying if the speed is increasing or decreasing? This is somehow easier. I can accept that. But applying the second method, you must memorize it. And I do not prefer this method. And sometimes you may forget it. So it would be really good if you learn the concept. Okay? Then you have a concave up. Look, in this part, the concave is up, right? It holds the water. Concave up. And when it is like this, the concave is down. It spills the water. When on a distance time graph the concave is up, it means the speed is increasing. And when on a distance time graph the concave is down, it means the speed is decreasing. Some students prefer to apply this method because this is easier for them. What is the point of the second method? We can apply this method because the distance time graph never goes down. It is not downward, it is upward. So we can apply this method and we can realize when the concave is up, the speed is increasing, and when the concave is down, the speed is decreasing. Okay, let's solve some examples because those key points may be a little bit complicated. So let's see what we have learned. Here, in the first distance time graph, or distance time graph contains three parts. This is the first part, second part, and third part. All of them are linear, right? So I can realize that S1 is constant, S2 is constant according to the key point 1, and S3 is constant. What else can I realize from this graph? According to the key point 2, when we have a straight horizontal line, look, in the second part I have a horizontal line. It means the value of a speed is equal to 0, really simple. And let's compare the speed of first part and third part. Which one has higher slope? As you definitely know, part 1 has higher slope in comparison with part 3. So I can realize that S1 is greater than S3, and S3 is going to be greater than S2 because the value of S2 is 0. Let's solve the next example. As you can see, we have two straight lines. So our distance time graph contains two parts. This is the first part and this is the second part according to the key point 1. I can realize that S1 is equal to constant, and S2 is definitely going to be constant because it is a straight line. Okay, let's compare them. Which one has higher slope? As you definitely know, part 1 has higher slope than part 2. So I can realize that the speed of first part is going to be greater than the speed of second part. Let's go for the next example. How many parts does this graph have? As you probably can guess, this graph contains two parts. This is the first part, which is linear, and this is the second part. What can I realize from the linear part? According to the key point 1, speed here is going to be constant. I'm going to show it with CTE. And for the part 2, because I have a curve, S2 is changing. I'm going to show it with CH. Okay, now I want to specify if the speed is increasing or decreasing for the second part. I told you first specify the initial point and ending point of the part, then draw two tangent lines. This is the first one and this is the second one. I'm going to call it 1, I'm going to call it 2 again. Which one has higher slope? As you definitely can guess, M2 is higher than M1, right? So I can realize that S2 is greater than S1. It means in this part, in this point, speed is higher than the speed of this point. So what can I realize from that? Speed is increasing, S2 is increasing. A second method which is easier, because this part is concave up, I can realize that S2 is increasing. How many parts does the next example have? As you definitely can see, it has two parts. This is the first part and this is the second part. Second part is linear, so S2 will be constant. And the first part is a curve. Okay, so speed is changing, but it is increasing or decreasing because it is concave down. I can realize that S1 is decreasing, and you can also apply the tangent line method. Here you can find more examples, and it was supposed to be your homework, but I prefer to solve the second one because there is a point in the second one. How many parts are there in this distance time graph? Look, you may think to yourself it has two parts. The first part is linear and the second part is curved. But I must tell you that this distance time graph contains three parts. Why did I divide the curve part into two separate sections? Because as you can see here, in this curve part, this is concave up. And in this one, this is concave down. So we must separate them. If the direction of concavity is changing, you must separate the part. So it contains three parts. First part, second part, and third part. Now it is really easy because this is linear segment. S1 is constant and here it is concave up. So S2 is increasing and this part is concave down. So S3 is decreasing. So when the direction of concavity changes, you must separate it into different parts. Here you can find another example, and I strongly suggest you to solve it at home. If you have any question or if you wanted to share your answer, please feel free and write it in the comment box. I will try to answer it as soon as it was possible for me. Thank you for watching this video.